Everybody, it's the crypto truth. Here to tell you the truth about crypto. Hey, check this out. So, Celer Network has been doing extremely well throughout the whole downtrend of the market. And I'm just wondering, like, what's going on. And I'm sure if you're watching my videos, I have never dug into it this deep. So I am going to actually go through the white paper right now and see what's really so special about this coin and dive a little deeper. As I remind you, this is not financial advice. And I had someone leave a comment saying, just because you say it's not financial advice doesn't mean that you're not responsible. And I'm like, look, if you buy it, it's your responsibility. It's not my fault if you buy it and it goes to zero. It's not your fault if I buy it and it goes to zero. If you're hearing it from me, I probably heard it from somewhere else. But guess what? I'm smart enough to know that I'm taking a risk on anything that I buy in the crypto market, in the stock market, any financial investment you make is always a risk. And you can't say I'm scamming you. You can't say I'm not telling you to buy this. I'm just giving you information to make your own decision. Educate yourself, people. Enough with that. I'm just going to go on with the video and go over this white paper and see what's so special. Celer IM overview. Interchain message framework. The paradigm shift for multi-blockchain dApps. Celer IM fundamentally changes how multi-blockchain dApps are built and used. Instead of deploying multiple isolated copies of smart contracts on different blockchains, developers can now build interchain native dApps with efficient liquidity utilization, coherent application logic, and shared states. Users of Celer IM enabled dApps will enjoy the benefits of a diverse multi-blockchain ecosystem with the simplicity of a single transaction UX without complicated manual interactions across multiple blockchains. So it's simplifying the process is what I'm getting here. Remind you, I'm not some super intelligent college graduate from Harvard, 8 years in the field of blockchain technology. I'm just reading this and understanding it to the best of my ability. So you guys comment below if tell me what you think, what your thoughts are at any point of this video. If you have a bright idea or if you think I said something wrong, correct me. I'm not perfect, neither are you. The Celer IM framework is very easy to use and allows a plug-and-play upgrade that often requires no modifications with already deployed code. As an example, Uniswap and SushiSwap can be transformed into a cross-chain DEX with just a single plugin. There have been some projects that implemented this functionality in production, such as ChainHop and Rango Exchange. In the above cross-chain DEX example, a user of SushiSwap can swap their ETH on Arbitrum to BNB on Binance Smart Chain with a single, simple transaction. Behind the scenes, the following has happened. ETH to USDT on the Arbitrum side via SushiSwap. USDT on Arbitrum is bridged to BSC via C-Bridge as part of the Celer IM framework. An interchain message to execute a USDT to BNB swap is sent to BSC via Celer IM. USDT to BNB swap on BSC side. SushiSwap is triggered by that remote call on SushiSwap. Very complicated. So, I mean, if that's the process it takes to get from point A to point B and they take care of all of that for you, I can see how it could be valuable. So this was last modified 6 months ago. Interchain app use cases. The current common practice of making a multi-blockchain dApp is done by simply replicating the same code on multiple chains where the liquidity, application logic, and states of the same dApp on different chains are completely isolated from each other. In fact, except for the UI and the protocol token, nothing is shared between these instances. This approach often suffers from low liquidity efficiency, disconnected states, and a degraded user experience. Celer IM allows dApps to tap into the true potential of the multi-blockchain world by enabling a single-click user experience that benefits from much higher liquidity, efficiency, and coherent application logic. Some high-level examples. DEXs that allow users to swap tokens across multiple chains from just one chain and with only a single transaction. NFT Bridge that allows users to send their NFTs across different chains. Yield aggregators that allow users to manage multi-blockchain vaults from a single chain. Lending protocols where collateral can be provided on one chain in order to borrow assets on a different chain. DAO governance protocols that allow unified governance mechanisms without requiring governance tokens to be moved across different chains. NFT marketplaces, where a user from one chain can place bids on an auction taking place on a completely different chain. Metaverse games, where users can interact seamlessly in the game with virtual items from various chains. New kinds of cross-chain asset transfer bridges with different liquidity models, validation models, or even privacy features that can be built and coexist under the same framework. In fact, C-Bridge can be seen as an asset bridge built on Celer IM. Let's walk through some examples in more detail, and then we can dive into a more technical flow walkthrough. Decentralized exchanges. Today, a multi-blockchain DEX has to build liquidity pools for the same key asset pairs on every chain they are deployed on. As a result, a DEX has to spread out the farming incentives across all of these different chains for these pairs. Even though the total liquidity across all of the chains may be fairly high, the liquidity depth of each pool on each individual chain is actually spread thin. Unfortunately, this harms the overall trading experience by creating high slippage. In addition, for users who want to make a trade for a token where deep liquidity exists on a different chain, they have to manually swap on the originating chain, use a separate fund bridge app, and then switch to the other chain to make the final swap. So this is starting to make sense. It's basically the liquidity in each chain. So you'd have to put liquidity in Pancake Swap, let's say, and then Sushi Swap. So while the overall liquidity might be $1 million, it's only 500,000 in each one. Or it might be 200,000 in one, 800,000 in one, which can cause the slippage to be higher in one than the other. And if you're switching it over from DEXs, so this simplifies that process. DEXs built using Celer IM have a significantly improved trader experience by automatically routing their trade to the deep liquidity pool with just a single transaction. With this innovation, a DEX project will be able to concentrate the farming incentives for a pair of tokens on a single pool, creating deeper liquidity with low slippage. So, I mean, I think that could possibly help with scalability, I would think. And it improves the use of DEXs completely. Lending protocols. Today, if a user provides collateral in a lending protocol on one chain, they can only borrow assets on that same chain. In order to borrow assets from a different chain, they have to withdraw their liquidity, manually move it to a different chain, then provide liquidity in the new chain's collateral pool. Seller IM enables a new kind of interchain lending where a user is able to seamlessly move their collateral from a liquidity pool on one chain to a pool on a different chain, all in a single transaction. Then they can directly borrow assets on that new chain. With this functionality, users will have a simple and clean UX that lets them accomplish what they need to without having to leave the lending application. NFT marketplaces today. If a user wants to participate in an NFT auction, they must have funds on the blockchain where the NFT exists. It excludes people who would normally partake in the auction but don't have funds on that particular chain. When a marketplace like OpenSea is deployed on a chain like Ethereum, a good chunk of the audiences that are on their chains are excluded due to the complicated bridging operations and high gas costs. This is me, because I really don't like going to several different blockchains, and there's stuff that I would actually invest in if it was just easier and I wouldn't have to trade these funds to this side and then get that coin and then trade that coin for the actual coin I'm trying to get. So making this easier is definitely a good thing for the crypto community. Seller IM can help to expand NFT marketplaces to reach a wider audience. An auction will have the ability to take bids across chains other than where the NFT was initially minted. On top of this, there isn't a need to make any individual cross-chain fund transfers before the auction results are finalized. This significantly reduces the cost of participating in an NFT auction, decreasing the barriers to entry and enlarging the trader pool for the marketplace as a whole. So this could make certain things just blow up, because this would make it to where I wouldn't need to go into another exchange or anything like that to get a certain item. I could get it from what I'm already in. So this is huge. So next, architecture walkthrough. How this shit works, I'm guessing. This section describes the Seller IM architecture, design pattern, and end-to-end protocols. Okay. Seller IM design patterns. In this section, we introduce the architecture of Seller IM via a step-by-step walkthrough of common application design patterns. Cross-chain logic execution with the accompanying fund transfer. For many interchain native applications, the core flow often involves the process of sending funds to one or more chains and using those bridged funds to do something on the destination chain. In fact, the DEX demo given above uses this exact pattern. Links to the demo code will be provided throughout this walkthrough. Nice little graphic. So user, DApp plugin, existing DApp, message bus, cbridge, SGN, cbridge, message bus, executor, DApp plugin, existing DApp. So source chain to destination chain. This all looks very confusing, but we're going to read through it and we're going to figure it out. And leave comments, guys. Let's all learn this together. If you're a fan or an investor or interested in Seller and you understand this stuff, leave some comments below. Spread the knowledge, my people. While the above flow diagram seems complicated, yes, you are right. It seems very complicated. We want to highlight that most of this flow is handled by Seller IM. What they're saying is this shit is complicated, but we got you. Don't worry about it. And that developers will only need to work with two simple functions in the framework's application template. I'm guessing it's going to be the DApp plugin and the DApp plugin. Step 1. User initiates a transaction to DApp. Instead of interfacing directly with the existing DApp smart contracts, a user now interacts, mark A, with a new DApp plugin contract to express their intention of cross-chain logic execution. This DApp plugin becomes part of the overall DApp business logic and may interact with existing smart contracts on the source chain. This is usually the only transaction that a user sends to interact with this interchain DApp. In the DEX examples shown, the transfer with swap function serves as this entry point that allows a user to express the intention of swap token A to token B on chain X and use the resulting token B to swap for token C on chain Y. Of course, users usually do not manually specify these intentions. dApps using this framework are expected to compose higher-level user intent to these kinds of function calls. Step 2, baby. dApp plugin sends a message and associated cross-chain fund transfer. Whew. After completing the necessary actions on the source chain, the dApp plugin sends the resulting funds and the associated message across to the destination chain marked BC. The message specifies the action that needs to be carried out on the destination chain. In the DEX's example, it is swap the bridge token B to token C and give token C to the user. The message and the fund transfer are automatically associated together by simply calling send message with transfer. The message is then sent to the message bus contract, and the fund transfer is sent via an asset bridge, in this case, C bridge. If you guys are still with me, give yourself a pat on the back because this is long and this is good. And we are all learning, so go ahead and pat yourself on the back, people. This is getting interesting. Note, Celer IM can utilize other asset bridges in this application pattern, while C-Bridge is just the first asset bridge that is supported. So plenty of bridges will get supported. Step 3, State Guardian Network. Routes the message and cross-chain fund transfer. To understand this step, we must first introduce a core component in Celer IM, the State Guardian Network. The State Guardian Network is a proof-of-stake blockchain built on Tendermint, not Tinder, Tendermint, that serves as the message router between different blockchains. Node providers have to stake Celer tokens to join the consensus process of the SGN as a validator. The State Guardian Network uses the same security mechanisms as L1 blockchains, like the Cosmos and Polygon's POS chains. Excuse me, guys. The Stargate Network Celer staking and slashing mechanisms are all implemented on Ethereum Layer 1 smart contracts. The SGN validator nodes are continuously monitoring the transactions happening on all of the connected chains. When a transaction triggers a cross-chain message event in the message bus contract marked D, validators will first reach a consensus on the existence of such message and concurrently generate a stake, weighed multi-signature attestation. This attestation is then stored on the Stargate Network. Is that right? State Guardian Network. I was thinking the Stargate Finance. The SGN validator nodes are continuously, we read through that one. All right. For the cross-chain asset transfer, the C-Bridge contract can be seen as a specialized message bus with built-in optimizations for this purpose. A similar consensus and attestation process takes place, marked E. Instead of relaying this built-in fund transfer attestation to an off-chain executor, the SGN, State Guardian Network, validators themselves send the on-chain transaction to the C-Bridge contract, marked F, and trigger the fund transfer to the destination chain's dApp plug-in contract, marked G. Again, Celer IM can be connected to any asset bridge, but starts with Celer's C-Bridge set as the default. Step 4. Executor performs cross-chain application logic. The executor's task is to read the stake-weight multi-signature attestation from the State Guardian Network blockchain and simply relay it to the message bus on the destination chain marked I. State Guardian Network. I'm going to remember that. I like to remember acronyms because it makes it better. When someone's like, what's a SGN? And you're like, shit. So, State Guardian Network. An executor can be run by anyone for any application as the functionality is simply relaying the message. Of course, dApps are expected to take executor incentives into the consideration as it is the entity that sends out the transaction and pays the gas fee on the destination chain. The functionality of the message bus is to check the validity of the attested message and verify that the associated payment has been received by the dApp plugin, Mark J. After that, the message, logic execution instruction, is delivered to the dApp plugin contract, which hosts the dApp's interchain business logic on the destination chain marked K. The dApp plugin only needs to implement the execute message with transfer interface. In the DEX example, this function will execute the token B to token C swap on the destination chain. Cross-chain logic execution without fund transfer. Many applications only need to send cross-chain messages or logic execution instructions without fund transfer. In the NFT marketplace, for example, if a user participates in an auction that takes place on a different chain, they will only need to lock up their funds without actually transferring them to the destination chain in order to place a bid. It is only after they win the auction that a fund transfer will be required. User, dApp plugin, existing dApp, message bus, SGN, executor, message bus, dApp plugin. So it looks like from this chart here, it goes from A to the dApp plugin, and that's when the dApp plugin takes over. Then it goes to the message bus, then to the State Guardian Network, then to the executor, then to the message bus, back to the dApp plugin. Whereas before it would go user, existing dApp. You would have to do all that in between work and then back to the existing dApp to the destination. The flow for this would just be a simplified version of the first pattern. The dApp plugin would only need to implement the logic to call send message on the source chain and then implement the execute message function on the destination chain's dApp plugin contract. Failure handling. Due to the asynchronous nature of the above interchain message patterns, failure handling should be considered as part of the application logic. In these application patterns, failures can happen in the following 3 steps, and they should each be handled accordingly. 1. Source chain dApp logic execution failure. This is not related to Celer IM and should be handled by the dApp business logic itself, e.g. deadline exceeded for a DEX swap. Fund transfer failed in the asset bridge. The source chain dApp will be notified via a common interface and handle the refunded asset transfer by either retrying the fund transfer or sending it back to the user. No risk there. Destination chain dApp logic execution failure. When a user's fund reaches the destination chain, the dApp logic execution can still fail at that point. The dApp developers should prepare for this and should implement fallback functions in order to handle such a failure. A common way to handle such a failure can be to stop the execution and send the funds to the user on the destination chain or transfer the funds back to the source chain. But it is entirely up to the dApp developer to implement the specific logic of the fallback functions. That was that sounded a little risky, in my opinion. Because it's basically up to the dApp, So it looks like they might have some stuff to work through on there. End-to-end workflow. This section shows the more detailed end-to-end cross-chain message implementation diagrams. Cross-chain message without token transfer. SRC app. At the source chain wants to send an arbitrary message to DST app at the destination chain without associated token transfer. Figure below describes the end-to-end workflow. The SRC app sends a message to the message bus contract on the source chain, which emits the message event. SGN State Guardian Network catches the event and collects signatures from all validators. The executor then submits the SGN signed message to the message bus contract on the destination chain, which will verify the message info and then call the message execution function of the DST app. User goes to SRC app, then goes to the message bus, message received, message sender, to the State Guardian Network, then to the executor, message bus, message receiver, message sender, DST app, message receiver app. Cross-chain message with token transfer. SRC app at the source of chain wants to send some tokens to DST app at the destination chain, along with an arbitrary message associated with the transfer. Figure below describes the end-to-end flow of such transfers. Blue represents token transfer flow, while green represents message passing flow. Numbers show time sequence, which means steps with the same number can happen concurrently. The SRC app sends both cross-chain token transfer and message passing requests in a single transaction. SGN catches and correlates both events, then completes the token transfer at the destination chain. The executor then submits the SGN signed message and token transfer into the message bus at the destination chain, which will verify the submitted info and call DST app to execute the message. So it's basically sending and receiving at the same time. So step 1 is SRC app to C-Bridge, to the State Guardian Network, to C-Bridge, back to destination app. So source app, destination app. And message receiver and sender, message receiver and sender. TX by user, token transfer via liquidity or per bridge, emit. Submit token transfer transaction, transfer token to destination app, message route, emit, notify completion of token transfer and associated message with validator SIGs, submit message token transfer into verify token transfer, execute message with token transfer info. Woo, this is deep. Fee mechanism, SGN fee. SGN charges fees to sync, store, and sign messages. Whoever calls, send message with transfer or send message and message bus sender should put some fee as in the transaction, which will later be distributed to SGN validators and delegators. The fee amount is calculated as fee base plus message length fee per byte. A lot of coding in here, guys. Executor fee. Executor charges fees to submit, execute message transaction. How to charge and distribute executor fee is entirely decided at the application level. Celer IM framework does not enforce any executor fee mechanism. Celer token utility. Network value accrual and fees. It is obvious that Celer token stakers and validators in the SGN State Guardian Network are indispensable in the smooth operation of the Celer IM, as explained in both of the above models. As such, users of Celer IM are required to pay fees to the State Guardian Network in return for its services of reaching consensus and storing attestations of the source chain messages, as well as the fund transfer. This is very much like a fee being paid for any other POS blockchain validators. These fees are distributed to the Celer stakers corresponding to the SGN nodes that generate the blockchain. So it all goes back to the stakers. So if you're staking Celer, This might be a reason for the rise of it. People are staking it, people are buying into it, and then a lot of people are still staking, so they have to hold that for a certain amount of times, which if people are still showing interest in purchasing, then staking is setting a base level and then it can rise above that base level. All right, this is very lengthy, guys, so I hope you're sticking with me. Development guide. The following section provide detailed guidance on developing multi-chain apps using Celer IMs. This is getting very lengthy. So I'm not going to go over all this because this is all the framework. Message fee. For both function calls above, message fees are charged in the native gas token. Here's how to calculate and query the fee. Receive message to receive cross-chain. So this is going into the framework and into the fees, the address, the sender. Do not forget to use the only message bus modifier, as message execution functions should only be called by the message bus contract. Receive a message with an associated cross-chain token transfer. A cross-chain token transfer could fail due to bad slippage or other reasons. That's typical and stuff like that. Contract examples. Now we provide a few examples to show how to build multi-chain dApp contracts on top of Celer IM. All source code can be found on our GitHub repo. So that's pretty cool. They give you kind of a guide on how you can build it. Here's a hello world example that sends and receives cross-chain messages with simple logics. Users call send message on the source chain to send a cross-chain message. The receiver side implements execute message to receive. So this is all the coding that goes behind creating your own. This is kind of basic HTML demand codes pretty much. So this is how the layout is. I mean, you could go into that hello world with token transfer. Here's a basic hello world example that sends and receives cross-chain messages with associated token transfers. Users call send token with note on the source chain to send some tokens with an arbitrary bytes note to the destination chain. The receiver side implements. Yeah, so this is all the coding that goes into it. Address sender, address token, UINT 256 amount, UINT 64 SRC chain ID, bytes node. So this is all the coding basically. If you're into this stuff, leave a comment. If you look through it, find it interesting or any flaws or anything that's really cool about this. I'm not the one to go to look at any of this stuff. I've practiced some basic coding before. I understand like it's mainly like commands of, if I say hello, you say how are you doing, and when someone types in hello, it'll respond with how are you doing and stuff like that. So it's all commands that if this happened, then there's another, or if this happens, or if this doesn't happen, then it would respond in this way. So it's all kind of like manual AI basically, and AI is learning how to do that on its own. So that's kind of what it is in a short sample. So yeah, if anyone has been through this coding and likes what they see, or if there's anything significant about it, leave a comment. But I'm gonna end that there. That's all I have to talk on this right now. So you guys leave a comment. Don't forget, I just gave you 35 minutes of value. Went through this whole thing. Went through this whole Celer Network white paper, so you don't have to. You don't have to read it. All you got to do is sit there and listen to me. Rewind it if you missed something. I went through the majority of it with you guys. So thanks for watching. If you've come this far, hit the notification bell. If there's another white paper you want me to go through, or a coin you want me to look at for you, just leave it in the comments and I'll make sure to do that. Thank you guys, and stay safe and Keep your research strong in the market. Don't get discouraged. You might lose, you might win. Either way, if it's something you enjoy, stick with it and just take it easy, take it light. Don't try to get rich quick. Take it light, do your research, invest what you can afford. Don't invest more. Um, this is not financial advice, so do with this information whatever you please. And thank you again for watching.